Have you ever thought about the vast and mysterious expanse beyond Neptune? We all know the planets of our solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and, of course, Pluto, which has now been reclassified as a dwarf planet. But what if there is something else, something so far out that it has remained hidden from our view for centuries? Imagine a planet, large enough to be 10 times the size of Earth, lurking in the farthest reaches of our solar system. This is not a theory, nor is it a fantastical idea spun from science fiction. Scientists are increasingly convinced that there is a massive, unseen planet out there in the dark zone of the solar system, somewhere beyond Neptune, possibly hidden in the Kuiper Belt or even farther. The search for this mysterious planet, often referred to as Planet 9, has been ongoing for more than a decade. It all began with an intriguing discovery about a group of objects located far beyond Neptune. These objects, known as trans-Neptunian objects, TNOs, orbit the Sun at incredible distances. For many years, scientists observed these objects without fully understanding why some of them seemed to behave strangely. Their orbits didn't quite align with the predictions made by the known gravitational influences of the other planets, leading to the idea that something, perhaps a large, unseen planet, was affecting their movements. This potential planet, currently known as Planet 9, has not yet been directly observed, but there are mounting indications that it exists and could be one of the most significant discoveries of our time. The concept of Planet 9 is not entirely new. Back in 2012, astronomers first began to suspect that a massive planet might be lurking beyond the orbit of Neptune. At that time, a researcher named Rodney Gomez suggested that there could be a large planet somewhere in the outer reaches of the solar system, a planet possibly the size of Mars or perhaps even larger, influencing the orbits of objects in the Kuiper Belt. This idea was based on the observation of strange orbital patterns exhibited by some of the TNOs. In particular, the object 2012 VP113, a large, distant object, had an orbit that didn't seem to match the expected gravitational influences from Neptune and other known bodies in the solar system. That's when Michael E. Brown, an astronomer famous for his role in the reclassification of Pluto as a dwarf planet, took up the mantle and began to investigate the idea further. Brown and his colleagues, Chad Trujillo and Scott S. Shepard, set to work analyzing the orbits of objects in the Kuiper Belt and using advanced computer models to simulate the gravitational effects of large, unseen objects. In 2014, they published their findings, suggesting that Planet 9 could be much larger than previously thought, possibly 10 times the mass of Earth. This was a striking revelation because such a massive object would be capable of causing significant gravitational effects on the distant TNOs, explaining the strange behavior observed in their orbits. According to their calculations, Planet 9's orbit could take it as far as 600 astronomical units, AU, from the Sun, far beyond the current outermost planet, Neptune, which is about $30 from the Sun. The hypothetical planet's orbit could also be extremely elliptical, meaning that for most of its orbit, it would be so far from the Sun that it would be nearly impossible to detect. One of the key aspects of Planet 9 that has fueled interest in its potential discovery is the way it affects the orbits of distant objects. TNOs, which include both large and small icy bodies located in the Kuiper Belt, are believed to be remnants from the early solar system. These objects should be scattered throughout the Kuiper Belt, following predictable orbital paths. However, many of the TNOs that have been discovered exhibit orbits that appear to be clustered in a way that can't be explained by the known gravitational influences of the Sun and the 8 planets. These orbits appear to be influenced by a massive object with a strong gravitational pull, and scientists have hypothesized that this object could be a planet located far beyond Neptune. In 2016, after analyzing the orbits of several TNOs, scientists concluded that the chances of these orbits being coincidental were incredibly low, less than 0.007%. This statistical evidence has only strengthened the argument for the existence of Planet 9. The orbital anomalies are so consistent that it's becoming increasingly difficult to explain them by any other means. This has led many astronomers to conclude that Planet 9 must exist, even though it has yet to be directly observed. It is an exciting prospect, as the discovery of a new planet in our solar system would be a monumental achievement in the field of astronomy. So why haven't we found Planet 9 yet? The answer lies in the planet's extreme distance from the Sun. Because Planet 9 is thought to orbit so far out in the solar system, it is difficult to detect with even the most powerful telescopes. Most of the time, the planet would be incredibly faint, and its location would be hard to pinpoint. It's not simply a matter of looking in the right direction. The area of sky where Planet 9 is thought to exist is vast. For comparison, the orbit of Neptune is about $30 from the Sun, while Planet 9 could be hundreds of AU farther out. The sheer distance makes it challenging to spot, and its elliptical orbit means that it would only be close enough to the Sun to be detectable at certain times. In addition to the distance, there is the fact that Planet 9 is likely to be an icy, dark world. The planet's surface would be incredibly cold, perhaps colder than any other planet in the solar system. This makes it even harder to detect, as there would be little sunlight to reflect off its surface. A planet of this size would be too far away to emit much radiation, and because it's likely to be made mostly of ice and gas, it would not have the same reflective properties as the gas giants like Jupiter or Saturn. This means that even with advanced telescopes, finding Planet 9 would be a daunting challenge. Despite these challenges, scientists have not given up on the search. In fact, the technological advancements in astronomy over the past decade have significantly improved our ability to observe distant objects. The development of powerful new telescopes, such as the Vera C. Rubin Observatory, which is currently being constructed in Chile, is providing astronomers with the tools they need to search the sky for faint, distant objects like Planet 9. The Rubin Observatory will have a wide field of view and will be able to take repeated, high-resolution images of the entire sky. This will make it ideal for detecting faint, distant objects that may be difficult to spot with other telescopes. The observatory is expected to be operational in the next few years, and it could play a key role in the search for Planet 9. Another tool that could aid in the search is the Nancy Grace Roman Space Telescope. This telescope, set to launch in the coming years, will be equipped with state-of-the-art instruments capable of detecting faint objects in the outer reaches of the solar system. With its large field of view and high resolution, the Roman Space Telescope could be the key to locating Planet 9. By observing the movements and the faint reflections of sunlight off the surface of distant objects, it may be able to identify Planet 9 and confirm its existence. In addition to these ground-based and space-based telescopes, the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile could also play a crucial role. ALMA is a collection of 66 high-precision antennas that can observe the sky in millimeter and sub-millimeter wavelengths, which are ideal for detecting cold objects in the outer solar system. If Planet 9 is found, ALMA could help scientists study its physical properties in detail. With these new telescopes coming online in the next few years, the chances of discovering Planet 9 are higher than ever. The combination of high resolution, sensitivity, and wide field of view offered by these instruments will provide astronomers with the best opportunity yet to find this elusive planet. If it is out there, the tools are finally in place to locate it. But what happens if Planet 9 is actually found? The discovery of such a planet would have profound implications for our understanding of the solar system. For one thing, it would help explain the strange orbits of distant objects like TNOs. If Planet 9 is confirmed, it would likely be considered one of the largest planets in our solar system, possibly larger than Neptune itself. This could change the way we define planets in our solar system. After all, if Planet 9 exists, it would be one of the most distant planets from the Sun, and its discovery might force scientists to reconsider how we categorize planets in general. The question of naming Planet 9 is another exciting prospect. If it is discovered, the International Astronomical Union, IAU, would be responsible for naming it. Given that most of the planets in the solar system are named after Roman gods, it's likely that Planet 9 would follow this tradition. Some researchers have suggested names like Janus, the Roman god of beginnings and transitions, or Nyx, the goddess of night, due to its remote, dark location in the outer solar system. Other names, such as Fortuna, the goddess of luck, could also be fitting, as the discovery of such a planet would certainly be a stroke of astronomical luck. It's not just the discovery of Planet 9 that excites scientists, it's the possibility of exploring this distant world. While we don't yet know if the planet exists, some researchers are already thinking about the possibility of sending a probe to study it. Of course, such a mission would be incredibly challenging. Planet 9's extreme distance means that any spacecraft sent to study it would take many years, possibly even decades, to reach its destination. However, if Planet 9 does exist, sending a probe to explore it could open a new chapter in our understanding of the solar system. If the planet's orbit brings it closer to the Sun at certain points, it might even be possible to send a probe to study it when it's closer to the Sun. As the search for Planet 9 continues, the next few years could be a game-changer in the field of astronomy. The discovery of such a distant planet would not only change our understanding of the solar system but could also open up new avenues for exploration. Whether Planet 9 turns out to be real or not, one thing is certain: the mysteries of our solar system are far from being solved. The hunt for Planet 9 continues, and with new technologies and telescopes on the horizon, the next few years could reveal the secrets of the outer reaches of our cosmic neighborhood.